Assalamu alaikum students. Today we have to read about refraction through glass slab. For that very purpose, I took a glass slab named as P, Q, R, and S, whose refractive index is N and whose thickness is T. It has been placed within the ear. So ray of light, this AO is the incident ray of light making angle I with the normal at point O. As the ray goes from rarer to denser medium, so it bends towards the normal because it goes towards the denser medium and makes an angle R. At point O dash, this very refracted ray again suffers refraction and comes out of the glass slab and is called as the emergent ray. This is called as the emergent ray, this is called as the incident ray, and this is called as the refracted ray. Incident ray, refracted ray, emergent ray. This emergent ray, and makes an angle E with the normal, and that's called as the angle of emergence. Now it has been found always in case of glass slab, the incident ray and the emergent ray, they are parallel to each other, but there has been a shift. That shift is called as the lateral shift. This is the perpendicular distance between the incident ray and the emergent ray. This is the perpendicular distance, and this is called as what? This is called as a lateral shift, and it is of thickness t. So we are going to calculate a relation for this very later shift. But first we will show that incident and emergent ray, they are parallel to each other. That we can show only by showing angle I is equal to angle law. Now according to Snell's law, according to Snell's law, we have sine I by sine R equals to refractive index of glass with respect to air at point O dash. As the ray enters the spherical glass slab, then we can say sine I by sine R is equal to the refractive index of glass with respect to air. But at point O dash, again by Snell's law, what we have? We have sine of R by sine of E, because now this angle is also angle R, because they are alternate interior angles. This is R, this is R, and now this is angle of incidence because it is the angle made by this very ray with the normal. It comes out to be what? Refractive index of air with respect to glass. But what we know, what we know refractive index of glass with respect to air is 1 by refractive index of air with respect to glass. So giving the respective values, what we get? We get, instead of refractive index of glass with respect to air, we will write it down like this: sine I by sine R equals to 1 of sine of R over sine of E, which implies sine I by sine R is equal to sine E by sine R. This and this leaves, which implies angle I is equal to angle E. When angle I is equal to angle E, that means incident ray and emergent ray, they make an equal angle. As PQ side is parallel to SR, as they make equal angle, that means they definitely, if this is like this, then this has to come like this. That is, they are parallel to each other, then only they can make the same angle. Now we will calculate the relation for lateral shift in right angle triangle O dash DO. In right angle triangle O dash DO, we have what? We have sine of this angle is, this whole angle is I, because these are vertically opposite angles. Now this is R, then this is I minus R. Sine of I minus R. Sine is perpendicular by hypotenuse, that is equals to O dash D by hypotenuse, that's O dash. What we have to calculate from there? We have to calculate, which implies O dash D equals to O dash into sine of I minus R. O O dash D, that is simply, which implies D equals to what? O O dash into sine of I minus R. Yes, let it be equation third. Now in right angle triangle, now in right angle triangle, which one? O dash N O. O dash N O. We have what we have? We have cos of R. Cos of R. Curly black hair. So base by hypotenuse, that is base is O and dash by hypotenuse, that's O O dash, which implies O O dash equals to how much? O N O N dash into cos of, no, that is O O dash, O O dash equals to O N dash by cos of R. Now using this value of O O dash in equation third, what we'll get? Use this value here. D equals to O O dash, we will write O N dash by cos of R into sine of I minus R. So D equals to O N dash. O N dash, that is the thickness of glass slab, that is simply T over cos of R into sine of I minus R. This is the equation for lateral shift. You have to remember, if now I is 90 degree, if now I is 90 degree, then sine of 90 minus R, that's cos R, then lateral shift will be, if I equals to 90 degree, then D equals to T, then there is maximum lateral shift. Lateral shift is equal to the thickness of glass slab. This is all for today. Tomorrow we will be with another lecture. Till then, Allah Hafiz.